Hello, everybody, and welcome to this month's Footsteps to Mars Hangout. My name is Tony Darnell, and I run Deep Astronomy. And as usual, we've got another great hangout planned for you today. We're talking every first Thursday of the month about Mars and trying to get us there. And there are a lot of people working really hard to try and get us there in a variety of different ways. And so we're going to be discussing one aspect of getting of the Mars mission, which is trying to make it as affordable as possible. We all know that it's expensive to be in space, and a lot of companies, a lot of government, or NASA, a lot of other governments are trying to make space as affordable as we can. And one of the ways to do that is to try and strategize a plan to get stuff out there first, so that waiting for us before we send actual human beings there. And there are lots of people talking about this now. We're going to talk about a few aspects of that this week with my guests. And so I hope you guys will have some questions and comments. There's lots of ways you can do that for with us, because this is a live event right now. We do this live every Thursday at 3 o'clock. And right now, the best way to do it is on on deepastronomy.com/live. If you go there, you'll see a live chat client set up. And I'm looking at it right now, and I see several of you joining and already beginning. So that's good. I'll look at that chat window. I've also got the YouTube chat, live chat feature enabled. It's in a window on my desktop here. Also on Twitter using Footsteps to Mars hashtag. And I will be monitoring that as well. Now, you guys may have noticed over the last few Hangouts that we no longer have our names at the bottoms of these things. And that is because I think YouTube is making some big changes to the Hangouts technology. And they took it away. There used to be a toolbox that we could use. So we don't have the names anymore. So I will be periodically, as the Hangout goes on, mentioning who our guests are, so that you know who it is and what our topic is. So unfortunately, that's happened. Also, I've noticed in the past few Hangouts that there have been a little bit of technical glitches, especially on my part with the ISP or the bandwidth. It doesn't seem to be clicking through quickly. There seems to be a lot of noise and bandwidth, and sometimes I drop out entirely. And believe me when I tell you, I've been trying to make that better, but my apologies in advance if that happens in this Hangout. That's one of the reasons I kind of do this introduction the way I do. Give these Hangouts a few minutes to get started, get things settled, and hopefully by the time we actually get discussing things, all of those bandwidth issues have kind of been connected and worked out and smoothed out a little bit. So I apologize for those in the past. In particular, the last Hangout, I noticed that the bandwidth kept getting really crappy. So unfortunately, I don't know what I can do about that. But anyway, thanks for your patience on this. Okay, Harley is in the middle of getting, my co-host, Harley Thronson, is in the middle of getting his iPhone updated at Goddard. And so apparently that's a big deal. And he took longer than he thought. And he's going to jump in here in about, hopefully 10 more minutes or so from his office. But he is my co-host. He's an astronomer at NASA Goddard. And he's the one that sort of puts together these Hangouts for us, because he thinks that, and I agree, that a weekly visiting the monthly visiting on this topic is an important one to kind of keep the discussion going for getting us to Mars. And so these Hangouts, by the way, we have them every Thursday, and they are endorsed by the American Astronomical Society and the American Astronautical Society. And they are an opportunity for the members of those two organizations to kind of get the word out a little bit about their science. We provide an outlet for these organizations so that they can do some social or science outreach of their research and work that they're doing. And so I want to thank both of them for endorsing us. But I have to say that while the Hangouts are endorsed by those two organizations, the opinions expressed in them are not necessarily endorsed. So just make that little distinction. Okay, so on with the Hangout here. My guests today are from various places, and I'll introduce them now. I will start with Dr. Rick Davis. He's at NASA HQ. He is the Assistant Director for Science and Exploration at the Science Mission Directorate in Washington, D.C. He's also a co-lead for the Mars Human Landing Site Study. Hi, Rick. Welcome.
Hey, Tony.
Also joining me is Dr. Bill. I forgot to ask how to pronounce your last name. Is it Cirillo?
Cirillo, yep.
Cirillo, very good.
No doctor, just Mr.
Oh, just Mr. Bill Cirillo. He's a senior researcher at NASA Langley Research Center, and also it says Amy on his little Hangout, but I know that's not really him. It's Tim Cichan. Is it Cichan?
Cichan.
Cichan. Thank you. I'm sorry, I do it wrong every time. From Lockheed Martin in Denver. He is a space exploration architect. So welcome back. I appreciate it. Welcome back, Tim. It's good to have you here again. Okay, so I'm going to have Rick get us started with this, giving us a summary of some of the efforts of what we're going to be talking about, the subject of this hangout. So go ahead, Rick.
Okay, great. Can you hear me okay, Tony?
And loud and clear.
Okay, great. So in December, it's called Achieving Mars 4 workshop was held. It's supported by exploremars.org, and that's actually a great location for industry, NASA, and academia to get together and work on projects that related to Mars. This particular year, we actually looked at all the what we call long poles or technical hurdles for actually achieving sustained human missions to Mars there. And so there were things like landers at Mars, habitats, or Mars transfer vehicle. And one of the new areas that we actually looked at was, for lack of a better term, would be logistics out to Mars, or a supply chain. And that actually is leading to a lot of really interesting ideas. They're just in a formative period. And so your audience, we really are counting on their questions to help us come up with even better ideas as we start to explore the potential of this. If you'll go to the first slide that I gave you there, Tony.
Okay. Yeah, I just want to point out I have that exploremars.org website up. It's real simple. You guys should visit it out. They push. I think they publish the proceedings of their workshops on there not too long after they've had them. But yeah, so yeah, go check that out definitely. Okay, so you want the first?
Yes.
The first that? Okay, I think it's this one. How's that?
Yeah, that's perfect.
Okay.
So within NASA, as a result of our Mars-focused efforts, which was called the Evolvable Mars Campaign, there really was a key concept that when we go to Mars and put people on the planet, we're going to go to a base. And so one of the things which we talked about on our previous Hangouts was that we want cool science, we want resources and all those kind of things. But the base is actually really, if you think about it, a logistics node, so that you can actually start to build up supplies and spare parts for the bad days when things break, and that you have options and create options. If you go to the next slide.
Okay, but so you're saying that the first step is figuring out where you're going to land so that you can put stuff there first, right? That's
right.
Zero. and this thing here is just sort of a typical exploration zone where you might pick. Is that what this is?
Yeah. So we're calling it an exploration zone because we're really focused on exploration. But in the middle, you'll see like a habitation zone, and this thing's 200 kilometers in diameter. So it's a big area, and we're counting on rovers to be able to traverse through these areas and do amazing science and bring in resources. But the key point here is that it's dangerous being on Mars until we get our technology up to the point where it's a little more routine. And so every time we want to go to the same place and start building up infrastructure and start building up supplies so that if something does go wrong, we have options. We've learned this in spades on ISS. Bill can talk to that, no doubt. But the idea that you have a node, if you will, that you're trying to build up this capability is really crucial for safety and and that sort of thing.
Cool. Okay. So here you said you wanted this one up?
Yes. So
okay.
The next one, it should be showing McMurdo.
Yep. Do you see it?
I don't see it, but I believe
Can the other Hangout guys? Can you see it?
We still see the exploration zone.
Oh, okay. So hang on then. Let me stop. And let me re-share my screen. Hang on. So as I wrangle this technology.
And and I can keep talking if you want me to talk.
Yeah. Do you see it now?
Yep.
Okay. There you go.
Okay, great. So what you're seeing here is the McMurdo station in Antarctica. As part of the AM4 team looking at logistics, and Tim was actually on it, we had representatives from the National Science Foundation who actually work Antarctica logistics resupply. And so you see McMurdo. McMurdo is really like that base on Mars, if you will. It's where you deliver stuff to build it, but it's more complicated than that. If you go to the next slide, Tony.
Okay, easier said than done.
Yeah, sorry.
Do you see it? Okay.
Yep, that one came right.
Okay, good.
Okay, great. So what you're seeing in this next slide is actually the supply chain all the way down to McMurdo and then pushing on into the South Pole. And that is a very complicated system where they, for example, at Christchurch in New Zealand are pushing stuff through multiple modes of transportation, and then they put it on ships and they get it down to McMurdo when the weather allows for it, and then they push it what needs to go out to the South Pole. And there is a strong belief, if you could go to the next slide, please.
Okay.
Okay, do you guys see it?
Yep.
Okay.
Okay, great. Does everyone see it? Because I don't see it.
Yeah,
Okay.
you're good,
All
you're
right.
good to go, Rick. Yeah.
So while I'm doing this, Rick, I want to back up a minute and say this is, you guys are doing all of this as practice, right? Antarctica is important because it's in a hostile environment. Getting things there is hard, and so you're practicing for Mars. Is that what?
No, I would say it slightly differently, Tony.
Okay.
Antarctica is a very strong analog for Mars, and the people who have been supporting research stations down there have been doing it for years, and they have learned what works and what doesn't work. And we're just trying to learn from all of it they've learned so that we could potentially apply what's appropriate to Mars missions.
Right. So it's a difficult place to get things to and from.
That's right.
Okay. All right. I guess that's where I was going. I just wasn't saying it properly, but yeah. All right. So what do we got here? Can you see it now?
I can't, but I think it might just be my screen. Can you guys see it?
Yep, we see it.
Yes.
Okay.
Great. So you should be seeing a picture of the globe, and what you see is stuff starting from Los Angeles and in multiple other places, working its way down to Christchurch. It can come in by ship, by airplane, by rail, any number of ways. Christchurch is like a multimodal node, and then they push down to McMurdo, and then they finally push what needs to go to the South Pole. And as you'll see on the next slide, which talks about established stations equals low risk.
Okay. Sorry, I thought I had that. That's what you meant. So yeah, it's
Okay.
up now.
So great. So then basically in the Antarctic supply chain methodologies, there's a strong sense of pyramiding, so that you're pushing supplies there, and you always have a fallback. If things really go bad wherever you are, you can fall back. And they are caching energy, foods, spares, and all that kind of thing. And they are really thinking about lifeboats / safe havens for when things do not go as you expect them to. And so it's really that methodology. If you'll go to the next slide, there's a slide that says Evolvable Mars Campaign.
Yep, we've seen this one before, I think.
Yes, you have. And really what this is doing is it's basically saying, where are the logical places that you could potentially put nodes, not presupposing an answer, but what we're really trying to do is where can you do it? And there's, roughly speaking, 3 places. There's a node where you might have something in the Earth/Earth-Moon system, maybe in cislunar space. And then there's a potential node in orbit around Mars. And then there's a node on the Martian surface. And then as our team looked at, and even on the Martian surface, that's not the end all, because eventually when humans learn to master Mars, that'll just be the launching point to go out to the South Pole equivalent or to go to other research stations. It essentially becomes this node through which the supplies that human beings need to live and survive, all this stuff can flow. And there's some real advantages in terms of thinking in terms of these nodes. And Tim's going to talk to some of those as we look at them right now.
All right. I guess before we start that, though, let me just, so we are we're using the experience that we're gaining from working and studying in Antarctica as data points for helping us gather what works and what doesn't work logistically for these remote areas and getting us to Mars. And so we're building on that experience. And there's all of these different nodes that one could use along the way from here to Mars. And so I just wanted to kind of summarize what you just said, Rick, in another way, just to kind of help maybe others who are maybe just catching up or just getting online with us. So go ahead. So Tim, yeah.
Tony, let me just add one thing. And it's not just Antarctica. ISS has taught this in spades to us as well.
Oh, of course. Yeah, we should mention that too. Yeah.
So basically any extended exploration really, or even campaign, if you will, really counts on the flow of materials that human beings need to live and breathe and work. So with that prelude, there's lessons to be learned at ISS, Antarctica, really any, Lewis and Clark, frankly, too. So with that, I'll turn it over to Tim.
Yeah, go ahead, Tim. So yeah, why don't you give us some of your insights into this?
Sure. And if you go to that last slide, logistic nodes are differentiated by. When we
hang on, let me just share my screen.
Sure.
Okay, I think I'm there. Go ahead.
Great. So when we look at the logistics nodes and how we do the trades and how we decide where we're going to put these as we go to the end goal of being on the surface of Mars, there's a couple of different options that pop out. And Rick mentioned both in the Earth-Moon system, whether in orbit around the Moon or high orbit around Earth, as well as in the Mars system, both Mars orbit and on the surface. And one of the things as we study and trying to figure out how to do this, looking at analogs like ISS in Antarctica, is how do we build out as we explore across these nodes, and how do we assign each node to certain functions as the system evolves. And so the nodes at the Earth and Moon space get us up high out of the gravity well of the Earth, but still a couple of days away from home to stage things, to bring things. Rick mentioned multimodal, which means that we expect that there will be multiple different providers of logistics, and that's a collection point. And whether it's consumables for the crew, or whether it's propellant or spare parts, they will perhaps come from different sources.
Oh, go ahead. I'm sorry.
No, go ahead.
I was going to ask, so doesn't the operational intent sort of dictate the location? I mean, they're kind of dovetailed, aren't they? For example, if you want something for long-term habitation, what node you would use to put that would probably be determined by its use. Like long-term habitation would probably go to Mars, or at least in Martian orbit, correct?
Yeah, and I think when we look at the different operational intents, the major nodes that we set up will probably have all three. They'll be the aggregation, refuel, resupply capability, but that'll also be a place where we can exchange modes of transportation. Hey, let's say that we're in Mars orbit and we want to go down to the surface. We transfer from our Mars orbit habitat into a lander to go down to the surface.
Okay.
That's the transportation exchange piece. And then the other thing to note is that we have the opportunity, which we're already planning to do in the Earth-Moon system, to have extended stays at the nodes themselves for science benefits. When we're talking about the next step after the first flights of Orion and SLS, we're talking about a habitat in orbit around the Moon, and being able to do science from that habitat, both because we're outside of the Earth's magnetic field in the deep space radiation environment, but also we'll be in orbit around the Moon, and we can do telerobotics of operations on the surface of the Moon. And the same thing applies for Mars. If we're at the node in Mars orbit, we can do similar sorts of science things, and perhaps even visit the moons of Mars. So we're looking at these nodes, and so of course the logistics is important, but the exploration and science that can happen at them is important as well.
Okay, I don't want to put a graph up here with a bunch of letters without explaining what they are. What is this HMO, and what is this EHEO? What are those?
Yep, so high Earth orbit.
Okay.
High Earth orbit is HEO, and high Mars orbit is HMO.
Got it. And what's ARRC over here in operational intent? What's that?
That's aggregation, resupply, refuel capability.
Okay. All right, good. So you've basically broken the problem down by two big spots between where you need where they're going to put things and what they're going to do. And sometimes the definitions of what goes where depends a lot on what you're going to do with it. So Bill, can I get you in on this a little bit? Tell us a little bit about, do you have anything to add to this sort of basic summary of introduction into using these logistical means of getting to Mars? What are you working on and thinking about?
So I've been working logistics for the agency on and off for the last 25 years or so. And so we've seen certain trends or certain behaviors. And what we're trying to do is match up what a deep space mission like Mars would need and how it differs or how it is similar to our current investments that we've been making in the International Space Station from a logistics resupply perspective. So it's important to us to take the lessons learned that we've had over the last almost 20 years of operating the space station, and then understanding the differences and then looking at analogs like the resupply of McMurdo to understand where particular strengths or weaknesses are in different logistics resupply philosophies. So that's what we've been doing here at Langley off and on for the last 25 years as we've investigated various ways to explore Mars and the Martian system.
Well, I'm sorry. Go ahead.
Sure.
No, go ahead.
No, go ahead.
Well, I was just going to point out that, oh my goodness, I just forgot what I was going to say. So
I'll fill that void. Sure.
Yes,
so
go ahead.
What I'd like to point out is that from my perspective, the investment that this nation and other partner nations has made in the International Space Station has been invaluable in teaching us things associated with with the long-term care and feeding of a highly complex and highly multifunctional system like the International Space Station. And so we've seen lessons learned like dissimilar redundant transportation systems to ensure the continuous resupply of the International Space Station has been fundamentally important in keeping...
What, say that again? Dissimilar what?
Redundant resupply capabilities. So we started off with the space shuttle fleet.
Right.
We had multiple orbiters. We started off with a Soyuz and a Progress system for the independent delivery of cosmonauts and astronauts, both to the space station and for return, and their Progress system for the delivery of cargo. We then introduced the Ariane transfer vehicle and the H-2 transfer vehicle for redundant, dissimilar resupply of goods to the International Space Station. So we had a multinational approach to keeping the facility resupplied and the crew fed and the crew delivered and returned. So we know that there are extremely valuable lessons to be learned from how we've cared and fed for the space station over the last approximately 20 years.
Okay, Bill. I mean, is that a real fancy way of saying don't put all your eggs in one basket?
Absolutely. Yeah. No.
So you guys have learned. So you guys have learned not to do that.
Absolutely. Yeah. Now the good news is because it was a multinational approach, and there were assets that each one of those nations could provide, there was an abundance of capability. Now we've decommissioned the shuttle systems. We've, on the U.S. side, replaced with a commercial cargo delivery capability that's also dissimilar and redundant in terms of what can be delivered by SpaceX and their Dragon and what can be delivered by Orbital and their Cygnus vehicle. So again, we've recognized the importance of having that kind of a multifaceted approach to ensuring the delivery of goods to the International Space Station.
Right. So in addition to the Russian component, the Roscosmos stuff, getting humans there, you're also starting to look more towards the commercial aspect. SpaceX obviously has a role to play, and SLS has a role to play in all of this stuff. So you guys are just trying to make it so that you're not depending on any one particular method, right?
Yeah, we're just trying to ensure that the lessons that we've learned from the International Space Station, apply in the future. Now, the station itself has taught us an awful lot about what it takes to care and feed. So you basically have to care and feed for the astronauts and the cosmonauts. Then you have to care and feed for the systems that keep those astronauts and cosmonauts alive. And so, from our almost 20 years of operational experience, we've developed a much deeper understanding of the maintenance items required to keep the systems functioning, that keep the crew alive. We've understood to a much better degree the amount of food and the proper type of food that needs to be delivered and how it has to be stored, and in terms of both conditioned cargo, in terms of both temperatures and pressures and how we've treated those things. In addition, we also understand both the requirements in order to get full utilization of the International Space Station to maximize that. And then we've also developed a deep understanding of just the amount of crew time that's required to both operate the space station, maintain it, and then have time left over for the utilization of the space station.
Yeah, I think it's great that we definitely have a good sense of how to, we've learned a lot from the space station. If anything can be taken from it, and believe me, there's been some times when I wondered what we were getting out of the space station, but you bring up some excellent points. Experience is definitely one of them. But I guess my question, Bill, and any of you can answer this, is how practical is that? I mean, we're looking, the ISS stuff you're talking about, and even the Antarctica stuff before that we kind of learned as we went along, and there wasn't a plan a priori. Okay, here is what we're going to use all of these different systems to get things to Antarctica, to get things to the space station. It kind of came as we went. Isn't the Mars mission, is it even feasible to do that for something as expensive as going to Mars?
Well, Tony, if I might, this is Rick.
Yeah.
So I would say that let's take Antarctica, because when they first attempted missions to the South Pole, there were definite fatalities along the way because the missions were not planned adequately with the appropriate logistics. And so, for example, I think it was the English, but some were depending on horses. They ran out of hay. Many died. And so if you're really thinking about the logistics supply chain, even though it was rudimentary, was crucial for the ultimate success that was had in terms of getting people to the South Poles and to return them.
Right.
But let me finish, if I might. And so what we're starting to realize is that we really need to look at this for Mars missions. It may not smell like the space station in terms of exactly how you actually execute logistics because of the long lead times it takes to get stuff all the way out to the Martian system. But that doesn't mean we don't go look at it. We absolutely have to, because the last thing you'd want to do is have a major catastrophe on the way out and have no safe havens, to protect the crew when they're there. And so we have to kind of adapt our view of logistics and try to figure out how it might actually apply to a Martian mission.
I couldn't agree more, and I think that's absolutely vital. I guess my point was addressing more to what Bill was saying about this dissimilar redundancies part.
Well, so
yeah.
Go ahead, Bill.
Yeah, Tony. My argument would be that absent the investment and the lessons learned that we've made in the International Space Station, our probability of mission success in terms of keeping the crew alive to safely take them and return them to Mars would have been extremely challenging. The lessons we've pulled out of space station in terms of understanding long-term maintenance of the complex life support system that we operate to keep the crew alive, we've learned some valuable lessons that from station that if you had gone back 25 years ago and said, okay, I'm going to pull space station out of low Earth orbit and send an equivalent system to Mars, most likely that crew would not have come home again.
So you're saying dissimilar redundancies is a safety issue. You really have to have them if you want to increase the chances of getting them.
I'm arguing that we know that dissimilar redundancy, because it can be implemented on space station in a somewhat affordable manner, has been invaluable. Our challenge going forward is, do we have the same capabilities for a Mars mission? And if we don't, how do we resolve the challenges of keeping a crew alive and the systems that keep the crew alive for an approximate 11 to 1,200 day period, which is what we're currently looking at for an average mission to Mars if we're going to stay on the surface for a fairly long time.
And apologies for missing.
Hi, Harley.
Yeah, apologies for
Thronson.
missing. Yeah, hi guys. I know. I think I know everybody here. So isn't this? So apologies, and I'm going to ask a question that's already been addressed. In one answer to the point they're just making, isn't this the purpose of these so far hypothetical cislunar habitation systems that NASA has started funding early design work on recently? We hope to have, by the way,
absolutely.
on those.
Oh, good.
Yeah.
Yeah. So as Rick pointed out, if we and as Tim have pointed out, the node concept, the caching concept, the safe haven concept, that all plays into. So not from just an affordability perspective, but at least from my perspective, this is much more driven by a mission success and a mission safety perspective. Having these nodes for safe havens, having these nodes as a place to cache stores, having this as a place to effect repairs, nodes like this become invaluable in terms of increasing the probability of mission success.
Okay.
Well, and if I might, so that let's just use a concrete example. So for example, propellant is king in Antarctica, and it's going to be king in going to Mars. And so the point is you want to pre-position propellant. You want to pre-position even other things like food and resources out there. That's a great opportunity for commercial entities, international partners to be participants and actually pre-position stuff out there. And it's going out via different paths so that it's not all hung on one vehicle. If that vehicle develops a major malfunction and it takes 3 years to sort it, and we had that happen with the space shuttle, then you actually have options to keep the whole thing going. And so it's that sort of diversity. Now we have to adapt it to the Martian conditions, but we got a lot of creative people that would know how to help us do that. On your audience here right now, I guarantee you there'll be 3 or 4 amazing ideas that we could pick up that would be really need to be looked at.
I couldn't agree more. They definitely are a good group of people. So
creative is the word.
And before we push off to Mars.
Okay, before you start, can you hold that thought real quick? I need to just do a quick introduction again. You guys are watching the Footsteps to Mars Hangout. We do these every month on the Deep Astronomy channel. My name is Tony Darnell, and we are talking about going to Mars, but doing by making sure we have different redundancies and putting resources and technology in place in various parts along the journey to help ensure the success. And my guests are Dr. Rick Davis. He's the co-lead for the Mars Human Landing Site study at NASA. Also is Tim Cichan from Lockheed Martin in Denver. He's a space exploration architect, and also Bill Cirillo. He's a senior researcher at NASA Langley Research Center. So I just wanted to do that because we no longer have lower thirds. Okay, so go ahead and finish.
You tell them about the 2 AASs.
I did already. Yes, I did that. Okay, go ahead, Tim.
Yeah. So, and then before we go to Mars, we're going to take that ISS experience and other analogs like Antarctica, and we're going to start doing operations in orbit around the moon. And so in that case, hey, we're not 60 to 90 minutes from being on the surface of the Earth. Now we're a couple days away, but we're not 1,000 days away. And so we can start practicing the logistics architecture at the moon, slowly building up the duration time that we spend there in deep space to make sure that we're ready for Mars. And then NASA's plan is before we go to Mars, to do a 1-year shakedown cruise in the vicinity of the moon to test out all these systems, to test out that dissimilar redundancy, and make sure that we're ready to go.
And if I might, I add, Tony.
Mm-hmm.
So the focus is on resupply and that kind of thing, which is a very crucial piece, but aggregation is also important. We have to stop thinking of spacecraft as airplanes. A spacecraft in orbit that don't have to go through atmospheres can be aggregated, as we've learned on ISS and spades.
What do you mean by that?
In other words, you send up modules, you hook them together, and then you can grow the spacecraft. So the vehicle that goes to Mars is often called a Mars transfer vehicle. Initially, it's probably going to be small like the space station is. But what we've learned is that human beings needs a lot of space, really, and particularly on longer missions. And so we can, over time, build up the size of that craft in a logical sort of step-by-step process, and you have to aggregate those pieces. And so these nodes are also serve an aggregation function that's really key, probably.
Mm-hmm.
Yeah, I mean, in a certain sense, Tony, the International Space Station was effectively aggregated in low Earth orbit over a period of time, and as each additional piece was added, the functionality of the system increased.
Okay, well, while we're on this topic of using different of the different nodes and the different redundancies to get there, I was reading an article, and I found out about this article from the Explore Mars website. So I know you guys must know about it. It was written by Chris Carberry and Rick Zucker, and the title of the article is "Are Lunar Fuel Depots Needed for Mars Missions?" Now, one of the argument they were making about that I got from this article was that we shouldn't be wasting a lot of time with the moon, because it's going to be expensive. Setting up a lot of infrastructure will be expensive. The moon may not even have the right resources that we need to get to Mars, or enough of them. And it could, and this is crucial, it could, just the act of doing all this stuff on the moon would delay getting us to Mars by decades or even generations. Now, I don't know if you guys have read that article, but it was I thought it was pretty thought-provoking in the sense that, well, that should maybe be a different goal. Let's go to Mars, but maybe let's also go to the moon. But let's all go to the moon so that we can get to Mars. That doesn't sound very cost effective. What do you guys think?
So Tony, I mean, let's talk about one of the current architectural constructs that's being looked at by NASA. We are using cislunar space in order to talk about the aggregation of mission elements in order to take us to Mars. We are not talking about going through the lunar surface currently, nor are we talking about extracting in situ resources from the lunar surface in order to support a Mars mission. The benefit of going to cislunar space and returning to cislunar space from Mars is multifaceted. Right now, even with the SLS system or even with an alternate commercial heavy lift launch vehicle, it would be extremely hard to go to Mars in a single launch.
Okay.
And so we're talking about aggregation of multiple stages, habitats, in space, propulsion systems, and so we have to choose a location in order to do that. There are certain attractive features, associated with cislunar for doing exactly that.
Okay, well here's
and returning there. So the article you're referring to talks about potentially the use of in situ manufactured propellants to support that mission. Currently, that is still an open subject in terms of, is it affordable? Does the delay period make sense? What is the cost of establishing an RSRU capability out of lunar regolith? Things like that. So right now, that's still being investigated, but we are primarily not talking about using cislunar space for that purpose.
And if I might,
you go ahead.
I totally agree with everything Bill said. And the only thing I would say is logistics nodes in extended exploration tend to assume lives of their own. In other words, other uses start to develop once you actually have a core node. And Tim alluded to this. I could easily envision eventually, the partners that are going to Mars essentially setting up a demand for propellant where they don't care whether it comes from the moon or from the earth or wherever. They just say they're going to buy propellant at X dollars, X euros, whatever, per kilogram, and then let those smart, creative providers figure out how to get it there. And if they can do it cheaper on the moon, well, then Merry Christmas, we just got the moon for free. But if they have to take it from the Earth, that's fine too. But you're actually creating an entirely new industry potentially by doing that. And frankly, why limit it to the moon? Why not let them take stuff out to the Martian system too? Under a similar type of construct. And I'm not saying that's the answer, but we need to look at this more holistically in terms of how we really use the strengths of American industry and also all of these amazing international partners for really pulling this off and actually giving the system robustness.
So going to that's a good segue into this workshop then. You guys meet periodically to discuss these things. Is that where your head is at? And Rick, you're making outstanding arguments for this. I'm loving what you're saying about this opportunity for other partnerships, collaborations, and commercial enterprises to get involved and make entirely new industries out of this. What's coming out of these workshops? You guys just finished one. What was the big takeaway that you guys got from the last workshop that you did? I mean, what's the big ideas that are coming out now?
Well, Harley maybe would be better to.
All right, Harley.
Oh my God!
Sorry, there you are.
So the big idea. If I wasn't sure exactly which of many workshops were all involved in that, so I take
the Achieving Mars workshop.
The big message. There's some terrific medium-sized messages if you want. The big message is there are a half a dozen, maybe a few more major elements. The term commonly used is long poles, major elements for going to Mars. And what the workshop brought together was around 6 experts inside and outside the government, aerospace, academics, scientists, and so on, to discuss, debate, critique each other's, and assess the achievability of those. On the time scale that NASA and other folks are looking at and sending humans to Mars, mid-2030, say, can, with proper investment, proper management, proper assessment of how they all fit together, can these 6 and 8, 9 elements be achieved, and how would they be achieved on the time frame of mid-2030s initial human missions to Mars. And we found, by and large, that once again, proper funding, proper management, that within about a decade, maybe a decade and a half, those long poles can be retired.
Yes. Okay.
And Tim and Rick, you were there. Is that the big message from the workshop?
Yeah, I think so. To me, I mean, and that's a really exciting message. Hey, in a time frame that's reasonable, we've got the technology and the developments either already or in work today to be able to go to Mars, and that's a great message. And you know, we've already started on our way, right? Between the Orion spacecraft development and SLS and the lessons we've learned on ISS, you know, we've gotten started, and we understand the long poles and what needs to be done, and now it's time to go and get things done.
Actually, and thank you, Tim. Actually, Rick, I would like to add one thing, picking up on what Tim said. I think the other, in a sense, the cultural, if you will, big message was there was near unanimous, lots of good discussion, minority opinions and so on, fair enough, but the agreement among the practitioners, the folks who are doing the actual designing of these missions, developing the technology on what needs to be done and when it can be retired, the commonality of agreement was huge. Rick, Tim, do you agree?
No, I would agree with that.
Agreement.
And actually, Harley, I'm going to add to one thing that both you and Tim were alluding to, which is that not only are these long poles not that scary, if all of the caveats that you put in there, but you could actually attempt an orbital round trip mission probably if you do it carefully sooner than maybe some would even anticipate. And you know, frankly, we always worry about risk. But sometimes risk is fascinating because if you don't know about the risks, you may not even realize they exist. And so the point being is that by never attempting to go, there are hidden risks we simply do not know about because we never even attempted to go. And so by attempting to do an orbital mission sooner than later, which these long poles suggest maybe is the case, that you would actually exercise a round trip and understand what it really takes to execute Martian missions, and that will teach us so much about pre-positioning stuff, safe havens, what it takes to keep the crew alive when you're talking these 1,100-day missions that Bill alluded to. And so we have to sort of step our way up into this massive step of becoming a multiplanetary species, and it's sort of smelling like there are options here that are pretty exciting.
Wow, that is great. Okay, so I need to take a step back because Larry Keese on the live chat is asking, would someone please define cislunar? And by cislunar, we're talking about CIS lunar, not SYS lunar. Can someone tell him what that is?
So the astronomer can speak up here. Unfortunately, it's a highly specific term in astronomy about a particular location, well, particularly a series of locations in the vicinity of the moon. The casual way we're using it, to your correspondent there, is basically it means some reasonably stable orbit in the vicinity of the moon. There are a variety of them. It gets complicated in a hurry, but it means a relatively stable orbit in the vicinity of the moon.
Right. And Hans Milling has a great question I want to get to because, both Rick and Bill, you guys were talking about the opportunities presented by corporations, making different resources available, all the different benefits of getting it. And Bill, you were talking about having these redundancies in place that were dissimilar. But the reality that's coming out of a lot of stuff, it's not giving me the impression that's where we're going. And I'm referencing specifically Elon Musk and SpaceX. He sounds like he's going to Mars independent of everything else in his own way. And if I'm saying anything incorrect or that you don't agree with, please correct me. But his question is, any comment on the plan SpaceX has to go to Mars, and is NASA going to work together with SpaceX on this Mars mission? Because that goes directly what Bill and Rick were talking about.
Well, we're already working with SpaceX. They are trying to send Red Dragon in 18, and then in 20 they want to go every 2 opportunities there. On 18, we're sponsoring some work. We're helping them with their entry, descent, landing, for example. And so there is a growing partnership, just as there was on the space station with the commercial providers.
But it doesn't sound very Mars centric. It sounds like let's just get them into, or let's get humans back into orbit.
No. We will learn so much. They're using, for example, supersonic retropropulsion to land on Mars. We have not done that yet. Both NASA and anyone else trying to get to Mars will learn so much from their attempts to do that we really all stand to benefit by working together.
Okay. Any other comments? You guys want to talk about SpaceX a little bit, Bill or Tim?
Sure. I mean, the investments that SpaceX is making right now in terms of returning their Falcon 9s to their landing sites, like as Rick indicated, they're already practicing supersonic retropropulsion. They're already looking at advanced GNC systems for targeted landings. So they're using enhanced manufacturing techniques to 3D print complex engine systems, much like NASA is doing. So, kudos to them for a multitude of investments that they're making that we as an agency at some point, need to take full advantage of if we as a nation are going to be successful in going to Mars.
Okay. Bill's friend just logged in and goes, cute kids in the background, Bill.
Okay. So I'm borrowing an office. So that would be one of my coworkers. Because my office was not presentable enough to be on live TV.
Here we go. This is Harley's daughter and son-in-law.
Oh, okay. All right.
My dog. There's my dog.
Okay, there we go. Okay, Larry Keys has a good comment. This goes to what Rick was saying about I think you said the propulsion or the propellant was king. He's like oxygen would be king. That would seem to be a very important thing as well.
So oxygen is actually part of propellant. And it's also important for people to live on, but the big one is propellant, really, for getting off the surface of Mars and that sort of thing. And so then you also need probably most studies are assuming it's methane, which means you need water probably to produce it. But the propellant for whatever launches off of Mars is like the big one that everyone tries to solve. But there's, ultimately, if you're talking a semi-permanent or permanent base on the planet, everything that you woke up this morning and used, toothpaste, a glass of water or juice or whatever, that the people on Mars are going to need it too. And that's a lot of stuff that has to go out there.
Yeah. But for crew use, when we talk about fluids and gases like oxygen, and this work is proceeding on the space station right now, we need to be able to recycle those things, to take carbon dioxide and to retrieve the oxygen in order to keep the amount of supplies that we need to send to Mars as low as we can do. And so we've got lots of great work going on in the station, and we'll continue that technology. But there's no way of getting around the propellant problem.
Well,
and so propellant dominates.
And I totally agree with what Tim just said, and I would even add, you don't have to have the machines recycle everything if you actually have a supply chain too. And so the answer is somewhere in between. And I would suggest that we're not smart enough to know where that mix is right now. What we do know is that when you demand that the equipment do a lot of fancy things like recycle urine perfectly or recycle all the air perfectly and never leak anything, that starts becoming very expensive after a while. And so there's a trade-off about when you infuse that technology into the system versus just sucking it up and actually sending it out there so it's there. And in reality, it's going to be some mix of the two.
Exactly.
And Tony, just to follow on, the majority of the studies that we've been conducting over the last few years have been directly you're looking at what is that balance? Where do I take my precious dollar resources and how do I invest them between my closed loop life support and my propellant production in situ and my EVA suits and systems, and where is a potential sweet spot in terms of balancing the investment dollars and getting the highest return from all of those systems to give us the highest probability of mission success.
Okay. John Suffill on the YouTube chat is asking a great question. He goes, well, he's a good comment, actually. I'll have you guys maybe respond. I don't think a major Mars mission could be done by just one nation. It will take several working together. And that seems to be the spirit of a lot of things you guys are talking about here today, with collaborations and with both corporations and also other agencies around the world. You're not going to try, NASA's not thinking they're going to do this all by themselves, are they?
No, NASA fundamentally feels that this will be an international endeavor, and not just international, Tony. It will be a commercial partners.
I know. I like that aspect. You brought that up several times. I think that's important.
Tony, we NASA have been working with our international partners through an international working group for the last 5 or 6 years in order to understand potential partner roles, partner contributions to supporting exploration beyond low Earth orbit. So Kathy Larini is the NASA lead for that activity, and she's been heading up a group of individuals within this agency that have been working with 14 other partner nations to look at both understanding potential future mission needs and potential partner contribution. So that's been an ongoing activity.
Right.
And we're putting it into practice right now with the European Space Agency providing the service module for the Orion spacecraft.
Yeah, tell us a little bit about Orion and what's going on now with that, with getting us to Mars.
Sure. We're in the middle of the build of the second Orion spacecraft. We'll be launching that next year. And it will do it's an unmanned test flight. But unlike the EFT-1, which stayed in orbit around the moon, we're going to the moon with the EM-1. And it'll be at least a 21-day mission, so a nice long mission to shake down the spacecraft and return to Earth.
Can you say again when it was? You cut out just a little bit. When is that happening?
Next year.
Oh, I can't wait. Okay, so Galaxia is back. Hi, Galaxia. She goes, do these specialists work for NASA? Sorry, I missed the beginning. And that is part of the reason why I need to take a quick break and introduce and say that you are watching a Footsteps to Mars Hangout. My guests today are Dr. Rick Davis from NASA HQ. He is the co-lead for Mars Human Landing Site Study at NASA's headquarters. Also, Tim Cichan from Lockheed Martin in Denver. He is a space exploration architect. And Bill Cirillo, he's a senior researcher at NASA Langley Research. And we are talking about logistics required to get to Mars and some of the different ways people are thinking about it. Harley just got through telling us about a huge workshop they have every year where they get together and talk about these things and trying to reach a consensus on that. So that's who we are and what we're doing. So where are we now, I suppose? We've got a new administration. We've got all these changes happening. I don't want to talk politics. I just want to ask, where is NASA looking? Where are there any areas that NASA is working on more intently than others, or where? Can you guys comment on that a little bit about what's next? Where are you guys heading now? What are you working on now? And I'll start with you, Rick.
Well, the focus has been trying to figure out how to do human missions to Mars, and so you have the SLS under development. It's doing tremendously. You have the Orion. We're many other aspects, including in situ resource utilization, which is a code word for using local resources, are being studied. There's really a tremendous amount of activities underway within the agency, pointing towards Mars. And so, the new administration needs to come in and figure out, what all's been underway, and then we work for the president. So the bottom line is, we'll see what changes they want to pursue, if any.
Okay, and a bit of a related question. George Caldwell is asking on the chat window, how big a problem is the economics and uncertainties in funding? Moreover, how many materials that are needed are yet still to be invented? I know that when they did, and the reason I find this question interesting is I know that when they built the James Webb Space Telescope, they designed it, they had the science objectives all met or decided upon, and then they had to go out and invent stuff. How many unknowns are there like that in this thinking of the logistics? How many things don't exist now that have to be invented?
So let me start, Tim, if you don't mind, and then turn it over to you. So, that's why logistics is important here, because, frankly, we know how to live and operate in space and low Earth orbit on board the space station right now. We do an amazing job. Bill can tell you, run rings around all of us telling stories about it, and we've even handled vehicle failures, whether it be the shuttle. SpaceX or orbital ATKs missions, or even Progress missions. And we handle them because we have a diverse supply chain and we've learned a lot of lessons. The trick is to adapt it to Mars. And so, we do have to adapt. And so, for example, these nodes are pushing at that idea, because if you have a supply chain that gets spare parts out there, the machines don't all have to be perfect. They could be, maybe, I'm just going out of the box a little bit, like space station equipment, as long as you know how to fix the parts and have supplies out there to use them. I'm not saying that's the answer, but we have to look at that range of options there to figure out an affordable way that gets us doing it, so that we really understand the risks of executing a Mars mission and can build that into the overall architecture. You learn by doing, frankly, to a large extent. And so logistics is a major player here. I think that's what we're saying we're starting to learn as a result of these kinds of studies, and as a result of everything we've learned on the amazing thing called the International Space Station.
Awesome. Okay. Well,
I think Tim had something he wanted.
Yeah, my only other additional point was that as far as what do we need to invent, the answer can be nothing, right? There's trades out there of taking exactly all the current technology we have and we can go implement. Where the new stuff, where the new inventions come, is making it even easier than where we stand today. Even cheaper, even more affordable, even lighter, even more efficient and reliable. So, and that constant churn of progress will continue. We need to design our architectures to take advantage of what's coming in the future, and stand on the shoulders of what we have now.
And it also, go ahead.
Sorry, and Tim just hit on a very crucial point, which is that you don't need to have all 35 miracles in place before you attempt the Mars mission. You have to figure out the subset that you really want to invest in. You go do it, and then you infuse in the new technologies as resources and time permits. But not ever going, we actually have those hidden risks that I referred to, because we just never executed. As Bill can tell you, on ISS, we have learned so much from actually doing. And we have infused technologies throughout the 16, 17 years of ISS, all along the whole time frame. Bill, do you have anything you want to add to that?
Yeah, Tony, in terms of the larger context, the long poles themselves were an identification of some of the key challenges associated with each one of the elements required to successfully enable us to go and land on Mars. So, for example, our current capability is landing approximately a metric ton on the Martian surface. We know that in order to sustain human presence, at least for a long term on the Martian surface, you'd like to land somewhere in the 20 metric ton class worth of payload. Well, to go from the 1 ton to the 20 ton, there will be certain technology advancements that are required, but most of them are from an engineering perspective and an integration perspective, not necessarily a miracle breakthrough in a thermal protection system. It's more, how do we put some of these things together? Again, we haven't made a choice as an agency on what our in-space propulsion technology approach would be. We are studying things that range all the way from storables to high power solar electric propulsion systems. Again, there's no miracle breakthroughs, but rather, again, engineering challenges that need to be addressed.
And I want to underscore something that actually all three of our guests have said, but most recently just now, or a few minutes ago, Rick said about you will learn so much the first time you go. We take a lesson from the Western expansion, Western exploration of the U.S. or of our continent in the 19th century. We did not wait until we had the technology to build the Transcontinental Railroad before we sent out Lewis and Clark.
Yeah, and I think that goes
so much.
Yeah, and I think it goes to underscores what Rick said earlier. I think it was Rick said that we could start doing things a lot sooner than we think. Going into orbit around Mars and coming back. Those kinds of things we can do now and sooner, I think, than we think.
Yeah, that was one of the purposes. That was one of the purposes of, among other activities, of the workshop to which we were referring earlier.
Right. So
and don't forget that we're continuing to explore Mars. The InSight lander is across the campus here in Denver, getting ready to launch next year to Mars.
That's right. We've got a lot of things running around on Mars. So soon it'll be us, I hope, and we're running around. And doing all kinds of cool things. Okay, I'm gonna have to cut the Hangout off here, guys. This has been a really great discussion. I want to thank all of my guests for joining me. We had Dr. Rick Davis from the from NASA headquarters. He's the co-lead for the Mars Human Landing Site Studies, also the assistant director for science and exploration at the Science Mission Directorate. Bill Cirillo is a senior researcher at NASA Langley Research Center, and Tim Cichan from Lockheed Martin in Denver, who is a space exploration architect and works on Orion. And don't forget, I'm just going to call him GW. Gravitational
wave duck.
Rubber ducky. That's right.
Yeah. Hey, Tony, thank you for the opportunity to. Thank you for the opportunity to participate. This has
You're
been
very welcome. Well, I hope you'll come back after you
Yeah,
guys.
thank you.
Yeah, definitely. Thank you. And I hope you guys will come back as you guys make more progress on getting us to Mars, because we all want to learn about how we're going to get there and how we're going to do it. So we're very interested in what you have to say. So thank you guys very much. Thanks so much for all of you guys for watching. On behalf of my co-host, Harley Thronson, we hope you'll join us next Thursday, where I'll be back with Dr. Carol Christian at the Afternoon Astronomy Hangout. Thank you all very much for watching. And as always,
Thanks.
keep looking up.
Thanks, Tony.
Bye-bye.